Some of you may watch my video on the build of this oscilloscope, which I did a few videos on, complete build on it, and yeah, this is a really nice piece of kit. But like I explained on the videos, I haven't really got a clue what to do with it. So what I did do is, at the same time as buying this, I also bought this, which is a signal generator with the idea of being able to put signals into the oscilloscope and therefore at the same time learning a little bit about how the oscilloscope works and reading waveforms and all the rest of it. Well, that's the idea. Whether I'm pissing in the wind or not, I don't know. But anyway, I thought we would first of all build this, and you can share the experience with me, be it a good experience or a bad experience. We shall find out. And seeing as I'm struggling to open the packet, that's not a good start. But ooh, there we go. Right, so this is the signal generator from Banggood, as indeed all my kits are. That is the acrylic case that will eventually encapsulate the device. Oh, there is the main PCB in there as well. We're going to want that. Let's pull that out. Let's pull the whole lot out and see everything. These cases, if you've not seen them before, are clear plastic acrylic, and they are covered in paper just to protect them during transit. And you can probably see they're see-through, and you just peel that paper off and then build the case up. We're not going to worry about that now, so we're going to put that to one side. And that is the main board that we shall be building the device on. Now I've got a different camera set up here. I've got my iPad mini, which is kind of suspended across the desk with one of those adjustable bendy arms, which is really not ideal, and the camera doesn't quite zoom out enough, so there might be a lot of jiggling about to try and get the camera in the best location, and so this is a bit experimental for me. The other camera I used, like the one built in the oscilloscope, was actually a GoPro, and it doesn't give very good quality, so I think this will be a better result. We shall see. Right, I'm going to change my specs because my eyesight is awful and my eyesight is also aged. There you go. I've knocked the camera and it's wobbling, and you're probably now feeling seasick. So I shall stop that from doing that. So there we go. The XR2206 function generator manual install. Function generator component layout diagram. You can see there it's all fairly straightforward. I think it's all through hole. We don't have any surface mounts, which will make life a little bit easier. What I will do is I'm just going to tip out all the components here and see what we've got. Put that to one side. That's a bag of hardware to build the case, so we can put that to one side. We have a few resistors of the same value. We have some, looks like these are jumper jumper pins, so obviously for bridging a couple of pins for whatever purpose, I know not. A couple of control knobs, in fact more than a couple. We've got 3 of those. Let's put those up there, and there we have the pots on which the control knobs will no doubt sit, and there is again 3 of those. There we go. We have a power jack, which is good because we need one of them. Again, more of these jumper pins. Let's put those over there. We have a block connector for screwing God knows what to. We have a chip with an IC holder. Just have a look what that chip says. It is a 2206CP F0918. Yes, whatever that means. Let's not worry about that. We have some capacitors. These aren't ceramic, are they? I can't remember what they are. I think these are all going to be the same value. 104. Oh no, they're not the same value. 222. 101. 105. And 104. Crikey, got the full set there. A couple of loose resistors. Are they resistors or inductors? Yeah, they're resistors. Oh, and another cap. What's this one? That's a 473. So they're all different values, those caps. We have some multi-pin connectors, which I would imagine we will use with jumpers. We have an electrolytic cap, which is, let's get a bit more light on the subject. The lighting is awful. That cap is, what value is that? 16 volt, 100 microfarad. Pretty straightforward stuff there, and a couple of smaller caps there. Get this thing to focus. Probably a little bit too close for it. There you go. What value are they? 10 microfarad at 25 volts. And another pin connector, block of 4. And some resistors, the values of which I will test before I use them. So that's all the components. That is the actual board. We have all the different capacitor values there. C8, C7, C6, C5. What else have we got? What I don't know is how much power this thing needs. Does it actually say what the voltage in is? So the power block goes there, but oh, you're right off camera there. I am sorry. So I don't know what the voltage is. Let's have a look. So there's all the components, and down here it tells you if there is a polarity issue. So for example, we have an electrolytic capacitor, and all electrolytic capacitors have a positive and a negative, and you can see there on that one the negative is marked and is always the shorter lead. So the longer lead is positive, the shorter lead negative. Capacitors, the other capacitors such as these, it matters not which way they go around. The same with the resistors, and so on. Okay, so we have got jack number 1, DC power. Yeah, but how much power? How much power does it need? Right, let's have a look on the diagram. Let's see where the power in is. Why can't I see power in? Probably because I'm just absolutely no use at reading circuit diagrams. And certainly not used to reading them. Why can't I see where the power rails are? But I can't see anything that tells me what the voltage requirements are, what the input voltage is, unless... there we go. Okay, so 9 to 12 volt power supply range. Supply more than 12 volt, the output waveform is unstable. That's fair enough. Can't argue with that. Okay, so it needs 9 to 12 volts, which is unfortunate because I don't think I've actually got a 9 volt supply, which is one that I use for the oscilloscope. And if you look at my light, there we go, you're bouncing up and down again. Okay, still for the oscilloscope, and that takes 9 volts, but I've only got one supply. So if I need to use a signal generator with this, and I'm going to need 2 9-volt supplies, which is a pain in the arse because I don't have one. I don't know if I can use a 9-volt battery, and even if I did, perhaps it might kill the battery in no time at all. I don't know what the power consumption is. So there we go. That's that. So it's something I shall have to consider. But in the meantime, what we need to do. Against such as please timely correction. So I'm reading some of this, some of the instructions. The components are welding the front board from low to high principles, namely the first low welding components such as capacitor resistors. So do the smaller components first and the larger ones at the end, and so on and so forth. I mean, this is all fairly straightforward stuff. It's a fairly straightforward board. It's all through hole components. So what I'm going to do is I'm going to solder all of this up, and then once I've done that, I will come back to you with an update as to where we are. And I think probably what I need to also do is to work out what I'm going to do for a power supply, and see if I've got one kicking around that will be suitable for the job. In the meantime, let's get all this soldered up and see if we can get it generating some signals. So with that, I will be back as soon as I can. Right, well, it's complete. Very, very simple build, all through hole components. Case was fairly straightforward. The only thing to notice is that the main board needs to be well, actually not bolted to the actual bottom plate, but you can see there is a nut and a bolt that go through the PCB, and there's holes at the bottom just for the end of the screw to poke through, and that's all you need to do. And that was the only way I could get it to fit neatly. These screws don't need a nut. There is a how can I describe it? There's almost a star-shaped pattern in the plastic which allows the screw to self-tap into. The sides are very intuitive. It's quite obvious where they go. Just follow the right cutout for the right component, and yeah, job's done. So what we have is a little bit of printing on the actual top plate. This knob is amplitude. I'm not sure what we mean by amplitude, but I'm guessing that would be the, I don't know actually. Whether it's the depth of the sine wave or the waveform that's shown, but I would have thought that was determined by settings on the oscilloscope. I don't know, but you can. I'll have to have a fiddle with that, and then whatever setting you've got, you can fine tune it or you can coarse tune it. These settings here determine the frequency from 1 to 10 up to 85 to 1 megahertz, and this jumper that will be a jumper there. So for example, if we have it, I don't know, 3 to 65 kilohertz, you bridge that jumper there, and the jumper at the top here you can set to either a sine wave or what they're calling a triangle wave. Again, I'm not entirely sure what that means. Here you've got outputs, you've got a ground, and then you've got an SQU, which I presume means square wave, and then SIN or TRI, which is sine wave or triangle. So I guess if you want a square wave, then you just use that regardless of which ones this is set to. But if you want a sine wave or a triangular wave, then you use this pin or this connector and put the jumper on either sine wave or triangle. So there's quite a few different settings here depending on what it is you want. Now, to really understand how this beastie works, I'm going to have to get it set up. So what I'm thinking is I need to get some wires into these 3 slots so that I can use the crocodile clips on the oscilloscope to attach them to, and then we can have a bit of a play. I've managed to find something that has a 12-volt output and has exactly the same barrel jack size for that connector, so that's good. So I've got two power supplies, one for the oscilloscope, one for this, so I can put the two together and we can have a play. Very exciting, isn't it? So let me set all that up. So I need to get some wires attached to this, which will make it easier to muck about with, because I've got no idea if this thing works, because the only way I can tell is to actually plug it into the oscilloscope and see if it puts anything out, and then I've got to work out the settings on the oscilloscope to see if I'm reading it correctly. It's all exciting stuff, isn't it? This is the problem you have when you haven't got a clue what you're doing. And there we go, one bouncy iPad. Let me see if I can stabilise that a bit. So there we go. I shall be back shortly after I've connected some wires to those outputs. Well, you've missed some excitement that I wasn't expecting, and the excitement was the deadly magic smoke. Oscilloscope, as you can see, working fine, but when I plugged in the signal generator, I got a quick puff of what I thought was smoke, and you can see it's almost like condensation. I don't know if you can. So let me put the light on. Yeah, you can just sort of see it there. So I think that capacitor there went puff. So, you know, I plugged it in, it took a few seconds, and then poof, that was that. And I'm pretty sure that capacitor has gone US. So okay, I decided, well, let's give it a go at any rate. It might be that the signal generator's dead. Let's put the light off because you'll see the screen. So what I've done, I've hooked up the probes to the BNC connector on the oscilloscope. I have put the negative to the ground lead on the signal generator, and at the moment I have got the positive connected to the sine wave, or triangle wave, if you like, connection on that block. And as you can see, I have got a trace, a bit flickery, but all over the place. And if I adjust the amplitude, you can see that is having an effect. And then I can fine tune it like that. I can make it a bit coarser and so on. Let's just try. Now at the moment I've got, it's on 0.5 volt AC. I don't know if that makes a jot of difference, I've no idea. The time base is 0.2 of a millisecond. So I'm thinking if we change that, there you go, 0.5 millisecond, 1 millisecond, 2 milliseconds, 5, 10, 20, seems to be struggling to read that, 50, 0.1 of a second. Let's bring it right down again. 0.1 of a second, 50 microseconds. Let's see how the yeah, so we can adjust that and see how fine we can make it. We can bring it together, and yeah, so I mean it's reading it. There is a wave there. So that is, let's bring it back to, let's see if I can bring it back to 0.2 of a millisecond, see if I can get a cleaner looking waveform. That's a bit spiky. I don't know, perhaps that'll do. And let's change that jumper, which is currently on sine wave, and take it out. Now it's gone sharp. But let's plug it into what they call a triangle, see if that makes any difference, and it doesn't. No. But if I put it on, now I'll put it back into sine again, and it's still on a peak. Let me put the positive terminal onto the what I think is the square wave. Yeah, so that now brings us to a square wave. Let's see if we can bring the amplitude down, or make it not quite so coarse. Let's bring the time base a bit. Like, that's a bit better. If I bring the amplitude down, I probably need to change the trigger level. Let's see if I can do that. He says, as if he knew what he was talking about. Let's see if I can. No, it's probably trigger it further up. See if that makes a jot of difference. No, it doesn't. If anything, it makes it worse. Mind you, that's voltage it's reading there, so I'm probably looking at the wrong thing. Let's select it across to that side, to the to that arrow there. And what's that changing? I'm not sure what that's doing. There's probably people watching this screaming at me saying, "It does this, you idiot." But I'm a novice, I just don't know. I've got to learn all this stuff. Give me a break. So, interestingly enough, we've had an explosion of a capacitor. I'm very sorry you missed that. But it is working. Let me just take the power supply out, see if that makes a jot of difference. It certainly does. So it is working from that point of view. So we do have a dodgy, we've either got a dodgy capacitor, or I've made a mistake somewhere in construction. I don't know is the answer to that, but never mind. But we have a little oscilloscope which, by all accounts, is working, even if the signal generator isn't really behaving itself. Well, that's definitely a square wave, at least. Well, I think it's a square wave. Let's see if altering that one makes a difference. Of course, I should perhaps, if I brought the frequency down, would that make a difference? Ooh. Yes, it would is the answer, but probably too much of a difference. Let's bring it right at 65 to 1. Nope. And let's bring it right down to the bottom. Again, I don't know what I'm doing, so I'm adjusting this stuff and not really understanding where I am with it. So let's leave it where it was for the moment. For the moment. Anyway, so you get the idea. This is generating a signal which can be read by the oscilloscope. So really, all this was doing was testing to see whether the oscilloscope, well, for me, was testing whether to see if this oscilloscope was working. I've had a nice capacitor blow up on me. I'm pretty sure it's the cap, but it's still outputting square waves and sine waves and all the rest of it. Whether it's giving out the correct frequencies and the correct waveforms because that capacitor's gone belly up, I have no idea. But it's obviously giving something out, and whatever it's giving out, the oscilloscope is reading. And I know the oscilloscope's working absolutely fine. Whether it's me who've, whether I've screwed up here, got a resistor in the wrong place somewhere, or whatever, I don't know. But I'm pretty sure the oscilloscope's okay. Of course, one of the things because there's all the other settings over here. Let's see if and that's interesting. There we go. I've changed it to 1 volt now, which kind of makes sense because we're showing 2.2 volts up there. So we've got our square wave. Changing the so we're changing the what's that one? That's the fine adjustment. And that's the coarse adjustment. That's interesting. Let's just quickly change it from the square wave back to the sine wave. because we actually got originally a proper sine wave. Now it's all zigzaggy, whereas beforehand it wasn't. I don't quite understand why. I'll tell you what I'll do. I'll take the power off, see if that makes any difference. Almost. It started off quite smooth. Now it's not quite so smooth. It's quite peaky. But it's doing stuff. And it's adjusting. And that makes me happy. So I've got to say that this isn't functioning correctly, because clearly something went pop, and I think it's that cap. I'm just trying to see actually if that is the side of that cap blown out a bit, or was it just the light? I'm going to have to open this up and have a look. It doesn't look deformed from the top, and the actual crown doesn't look deformed. It might even be one of these poly capacitors, I don't know. Oh, it's exciting times. I shall have to investigate that. So I'll call that an 80% success, from the simple point of view that clearly there's a problem with the signal generator, but 100% success for this little oscilloscope. So I've now got some, I know it works, I know how a signal generator works, all of this in principle, but I've got something to work with if I want to delve into the world of oscilloscopes in a bit more detail. I can use this to learn a little bit more about what oscilloscopes are, what they do, how to use them. If I ever need one, who knows. Anyway, there we go. So that's the signal generator. Bit of a fail, bit of a success, depending on how you look at it. Hope you enjoyed the vid, and got some more kits to build, clocks and God knows what else. So we'll have a bit of fun with those. So I'll see you next time on that. In the meantime, have a good Easter, because today is Good Friday 2018. Don't eat too many Easter eggs. I will, but you shouldn't. All the best, and we'll catch you on the next one. Cheers.